Okay, welcome to video section 4, chapter 4, section 4. Let's go ahead and select a pen, a blue pen, and we'll go to full screen. Great. So what's the difference between section 4 and the previous section 4.3 is that we are now going to look at factoring, well, really harder quadratic functions, and the reason it's harder is because we're going to put a number in front of x squared. So here we go. I actually took the key version of the notes. I thought there was a lot of handwriting and might help. So first of all, the first example 1 is going to be putting a number in front of x squared. So there's a 2, and also where the c is a number greater than 0, so a positive 7. So the idea here is that we look at the factors of 2, and we would split those up and put them as what they are calling variable k and l. And then we'll look at the factors of the number 7, and we'll split them up and put them in for m and n. And very busy instructions here. So where k and l are factors of 2, and m and n are factors of 7. And then because 7, m times n, is greater than 0, they have to have the same sign. So they either have to be both positive or both negative. And then because the middle term is positive, then we determine that they both have to be positive. So we can eliminate. Again, if you have a positive 7 and a negative here for 9, then both the factors of 7 would have to be both be negative. So they generate this nice table, which I don't expect you to do, but you definitely need to kind of sort out, all the possibilities. So 2 has 2 factors, 1 and 2, and 7 has 2 factors, 1 and 7. So you're either doing a combination of 2x plus 1, x plus 7, or you're doing 2x plus 7, x plus 1. And here I urge you to you have to try different combinations. Nobody, unless you're really good, looks at the original equation and sees right away how it factors. We all kind of go through trial and error. So here, notice with this first combination, my middle term would be 15x, and that's not correct. So we'll eliminate that in the second combination. If we put 7, then 1, I'll get the correct middle term. Let's look at another example. So this example 2, this is where c is now less than 1. So this is this negative. And to get two numbers to multiply together and get negative, you have to have one positive and one negative. And so basically you have to have opposite, what they'll say is opposite signs. So the combinations get actually a lot more here. So here 3 has factors of 1 and 3, or 3 and 1 in their order. And then check out all the possible ways that we can break down the factors of 2, where you're either positive 1 or negative 1, you're either positive 2 or negative 2. So you've got all these possibilities. And notice, again, from the table, the whole name of the game, the magic here is, what's the middle term that comes out? And again, I'm going to say this a lot in class as well. You cannot expect to start this problem and see the correct answer. You just have to try. And every time you try a combination, you kind of learn a little bit. And before you know it, you find the right answer, right, which is the second possibility. So again, if you're lucky, you figure it out the first time. If you're not as lucky, you figure it out after a second iteration. Again, you could have to go through 3 combinations. In the worst case, you go through all of them. But the answer is going to be in there. So again, don't give up. Once you go ahead, hit pause, see if you can't do these. Again, you've got a little bit harder ones. You've got factors 3 and 1, and 20 gets hard, right? Because you could either do 1 and 20, 2 and 10, right? Or factors of 4 and 5. So you've got a bunch of combinations. I expect this to take a little bit of time. Here 5 is a nice number because the factors are 1 and 5. 6, again, you could have combinations 1 and 6, 2 and 3. And again, here, because of this negative, one of your factors is positive, one's negative. And this guy, that makes more work, by the way, for 1. 2 is better problem because of the positive. So they're either both positive or both negative. Oh, they're both negative because of this guy. Hopefully those cues helped you. Go ahead and hit pause and and check the answers out in a second. And there you go. There are your answers. So hopefully you got them. Again, you know you got it because you should always check after you factor. And again, it's a patience game. How many different ways are you willing to try? So you've got some special patterns similar to what we saw in section 4.3. This first one is called the difference of two squares. And so notice the 4x squared is really 2x quantity squared, and 9 is the same as 3 squared. So you get into this nice pattern of 2x plus 3 and then 2x minus 3. Again, what makes this difference of squares is that the middle term gets canceled out. 6x plus 6x, when you add it to negative 6x, goes to 0, and that's why it's not written here. Now, the second two, again, are really nifty. If they happen, you're kind of excited, right? This is 9y squared and 49, which is, really 3y squared is the same as 9y squared and 7 squared. If you had the difference, right, you would get this third example. These guys, again, if you recognize them, that's cool. I don't expect it as much. The A, difference of squares, that's a must. You really, and again, it's great to see it because it's always a binomial. The B term is missing, and these guys are squares. So you should really get good at difference of squares. We'll practice more of those. Why don't you go ahead and practice these guys? Again, just, you might look and see the 16y squared, let's go to 4y for that, and the 25, the square root of that is 5. And then this guy, 100% difference of squares. See how you can factor them. Go ahead and hit pause. And there are your two answers. So this step, probably one of the most important and hard to know when to do it. But notice in example A here that each of these two terms in this binomial have the same factor of 4. So knowing to first factor that 4 out, and then your second step is to say, hey, that's a difference of squares. It's going to be really important. Here again, both terms have negatives. I factor that out. Both terms have a factor of 3. I factor that out. And both terms have a factor of y, and I factor that out. Notice what's left over in red cannot be factored, so I'm done. But here, like problem C, big time problem, right? Because of the fact that there's two huge steps. First one is to recognize that there's a common 2, and then it's kind of your decision whether or not to factor out a negative. I would, right? It's nice to get the leading coefficient, the A coefficient, to be positive. So factor out a negative 2. When you're done with this quadratic, you can now see, hey, this guy factors. So this is about as hard as it's going to get for us, and definitely a hard problem. And notice here, when you factor out a 5 for the fourth example, what's left over doesn't factor, and that always feels kind of a disappointment, but that can happen. But you go ahead again and hit pause and see the answers. Maybe start off real quick and just notice that there's a common, this 36 and 16 has a common factor, and then also notice, here it looks like there's a common factor of 3, and there you have it. So I had the common factor of 4, and then you had a difference of squares, right? It was 9x squared minus 4. And then here, a little trickier again. If you got 6, boy, you're doing really well. We'll practice more of these tomorrow. So what's the point of all this? Well, you're factoring to solve quadratic equations. So this, again, example 5 is where we're going, right? This unit is quadratic functions. So how do I solve this? And, realize when you solve this finally for these 2 points, these are the x-intercepts. These are where, when y is 0, the function exists. Also, a big deal here is for those of you that always thought I just take the opposite sign, right? That's not the case for this one. If that, a common mistake, and let's bring it up, like to look at this factor and say the answer 7 is not correct. We set the whole factor equal to 0. We add 7 to both sides and divide by 2. So be real careful. Here it works. Opposite sign 3. It says plus 3 here. It becomes negative 3. But it's really algebra that we're doing. Example B here, check this out, right? So you got 5 different terms. Your first step is just kind of a cleanup step. Hey, combine like terms, right? Set the function equal to 0. Combine the r terms, combine the coefficients. Then notice you can divide everybody by 4, including 0. and get to this easier quadratic. This is a great opportunist move, right? You really want to be looking out for that. Notice all the fours, the factor of 4 in all three terms. This factors, and then you solve for r. And a couple more examples if you want to try. Look at the first problem. I think you see a common factor of 2, right? Hopefully you do as well. And then 8, you're going to have to first just sort out the equation, combine like terms. Here come the answers. Hit pause. And there are your answers. So let's see, I wrote it down just for the sake of time. I factored this first one. You know, I went to x squared plus 2x minus 15, and then that factored to x plus 5 and x minus 3. And then the second one, this is again equal to 0 and solved. And this one went to z squared plus 8z plus 16 equal to 0. And that was a perfect square of z plus 4 quantity squared. And so you only get one answer. That's pretty neat. As a parabola, that means the vertex is lying on the x-axis. Okay, see you tomorrow.